The study of biological classification, taxonomy or systematics, is indispensable to science and society. Even without training in biology, one can readily appreciate the value of names and descriptions of different kinds of organisms. Is this plant edible? Is that animal poisonous? What is that creature? Clearly, names are the keys to essential knowledge, and the means of communicating that information. Although one might expect that the task of discerning and naming living things is straightforward, in fact, natural variation of plants and animals is extraordinarily complicated, and biological classification is based on sophisticated philosophy and complicated procedures. The theoretical and pragmatic issues of taxonomy are critically centred on what has come to be known as the species problem. Ernest Small, 1979. Taxonomy is, ironically, a science that much name recognition, but it has so many stories worth telling. Taxonomy is the science of naming and classification, from taxis and nomis, meaning arranging and distributing. Those arcane-sounding Latin names, familiar from dinosaurs, zoo and museum labels, or garden centres, are all taxa, a hierarchy of labels denoting categories used to sort the relatedness of all living things on Earth. Popular science often offers folkloric versions of scientists. Balancing narrative and interest with rigour and sufficient context is difficult. Many of us only learn about these figures as children or from pop culture. Which child hasn't heard the story of Isaac Newton's apple tree? But how many adults would feel confident in explaining his laws of motion? I certainly don't. I think Wikipedia pages are a great way of measuring the cultural knowledge about and interest in a given topic for different language communities. On the English language Wikipedia, Newton's apple tree has a much longer article with twice as many sources as does Malus sieversii, a threatened species that contributed the bulk of ancestry to all of our modern domestic apples, including Newton's. Additionally, when people learn history from biopics and fables, they are encouraged to become emotionally involved with historical figures, forming what are essentially parasocial relationships with their favourite historical celebrities. The demands of narrative remove various characters, play familiar tropes, flatten long periods of time to tell a compelling story. Many people think of Lamarck and Darwin as rivals, which is just chronologically wrong, or believe that Linnaeus was the first person to put forward a taxonomic system. Rarely do scientific developments occur ex nihilo in the mind of one individual, but they evolve through time alongside the words we use to describe them. It can be easy to assume, anachronistically, that Linnaeus was sorting organisms by their relationships, while in fact his system was based on shared characteristics. We now know that those similarities often did reflect shared ancestry, and that certainly is the basis of modern phylogenetics, where life is purposefully grouped based on genetic relationships. However, we have no evidence that Linnaeus believed that these similarities demonstrate anything except affinity between different creations of the same divine origin. Obviously these ducks were all created by the same god, look how similar they are. The best way to understand the developments of historical ideas in science is by following them through the historical literature. Often histories of taxonomy start here, with Systema Naturae by Carl Linnaeus. But that's not even the start of Linnaean taxonomy, that's just the first book that humans appear in, so let's start a bit further back. 1583, De Plantis Libri 16 by Andreas Alpino classified 1,500 species of plants based on the tangible characteristics of their fruits and flowers, in what's considered to be the first botany book. His work in botany stands apart, although obviously descended from medieval herbals, in the start of a systematic approach. Alpino was also a physician who made contributions to medicine and geology, but this timeline has to move fast, so there's a lot I can and won't cover, even on those people who I am including. 1676, Francis Willoughby's ornithology, published posthumously, tries to catalogue all known birds. It introduces a system of classifying birds based on their features. For ease of use, it includes an identification key and 80 illustrations. When Willoughby died at 36, he had researched and written on many topics, much of which has sadly been lost. He studied insects and fish, but he also had an interest in games. 1686, and John Ray begins publishing Historia Plantarum. Ray was initially the tutor and later a friend of Francis Willoughby. He was responsible for completing and publishing much of Willoughby's surviving material, including his ornithology. Besides preserving Willoughby's work, he was an influential botanist in his own right, who among other taxonomic developments separated monocots and dicots. 1700, Joseph Piton de Tournefort publishes Institutions Rei Herbarii, which was not the best system of classification we've seen so far, missing some of the developments that have been put forward previously, such as John Ray's division between monocots and dicots. However, his system would be hugely influential in the next 50 years, and for longer in France. 1735, and we get the Columbarium. Columbarium's approach to classifying has evidently been influenced by Willoughby's ideas, even aside from citing him as a source. However, the Columbarium is focused on just domestic pigeons. As far as I'm aware, no image of Moore survives. He is best known, outside of pigeon circles that is, not for his own work, but for being a quack doctor and a literary punching bag, roasted by no lesser luminaries than the Scriblarians, a hugely influential group of authors and satirists. Either Jonathan Swift, or more likely Alexander Pope, wrote a mocking eulogy upon Moore's death, and here's the most savage bars. O learned friend of Abchurch Lane, who sett'st our entrails free, when is thy art, thy powder vain, since worms shall eat even thee? Moore names all the breeds of pigeons known in England at the time, and gives them proto-taxa, reflecting similarity as well as historical relationships. It is, among other things, a markedly Islamophobic text. Yes, I know it's the foundational English text on keeping and breeding pigeons, and it seems like subjects like religion should have very little role in animal husbandry or biology, but we will see repeatedly how often this is not the case. The start of Linnaean taxonomy. 1753. Species Plantarum. Linnaeus publishes his work that is considered the starting point of modern botanical taxonomy. And in 1758, we get Systema Naturae 10th edition. In the 10th edition of his work on animals, Linnaeus applies the same principles to animal taxonomy that he had just done to plants. Humans are included as primates. Linnaeus has been much discussed elsewhere. I've already mentioned him a few times, and believe me, we will be diving into his work repeatedly in future. 1765. The treatise, a very influential pigeon text, based heavily on the earlier Columbarium, but with far less effort to sort breeds or keep up with taxonomy. There's less Islamophobia, but more anti-Catholic sentiment. Didn't see that one coming, did you? There is so much to talk about just in the books, many not on this timeline, that descend from the Columbarium. In 1787, we get a book which beautifully illustrates several important things, aside from birds. The Natural History of Birds, containing a variety of facts selected from several writers and intended for the amusement and instruction of children. This book, put together by Jeremiah Johnson, is openly a sort of compilation of information from other works, one which seems to do rather more synthesis and less duplication than the treatise. This book, aimed at children, and which does not apparently put forward any new or revolutionary information, tells us on page 5, all animals in a domestic state become variously marked, and further points out that pigeons breed fast, and therefore vary more than other domesticated species. This 18th century kids book is casually dropping ideas that will be studied by Darwin in the 19th century and proved by domestication science in the 20th century. 1794, Erasmus Darwin publishes the first volume of his Zoonomia, finished in 1796, a text with proto-evolutionary themes. Erasmus Darwin is neither the most famous Erasmus nor the most famous Darwin, but to give him credit, he is apparently the most famous Erasmus Darwin. He was co-founder of the Whig-supporting Darwin-Wedgwood family, and an abolitionist, strongly opposed to the slave trade. In 1800, Jean-Baptiste Pierre-Antoine de Monnet, Chevalier de Lamarck, gives his first lecture outlining evolution. Lamarck suggested that attributes acquired by organisms during life are passed on to their offspring. The famous example usually quoted is that generations of giraffes, straining to reach leaves, progressively stretch their necks further and further to reach high leaves. It's easy to criticise Lamarck's model of evolution now, but he was trying to solve a puzzle that still lacked several pieces, and it's worth reflecting on some of the things that he got right, such as adaptation to environment and gradual change over many generations. Lamarck, like any honest investigator, also developed his ideas over time. He published several books, such as Philosophie zoologique in 1809. 1813, Augustin de Candolle publishes Theorie élémentaire de la botanique, which finally coins the word taxonomy for this science that we've been watching develop for over 200 years. This book also pitched a revised plant classification system. This is a good chance to highlight Augustin Pyramus de Candolle, founder of Geneva's botanical dynasty. Despite not subscribing to evolution, he was the first writer to identify that not just animals but even plants are in competition with each other. The war of nature was an idea which would help set the ground for later developments. 1827. John James Audubon, namesake but not the founder of the USA's Audubon Society, begins publishing Birds of America, 1827 to 1838. This year includes the infamously fraudulent Bird of Washington. But alongside bird fraud, we should acknowledge that Audubon was not just a proponent of slavery, but an active and open trader in enslaved people. 1844. Charles Darwin wrote his first essay in evolution. This was not published, but later given in evidence of his work during the discussion about whether Darwin or Wallace had priority. You can read it online. 1855. Alphonse Pyramus de Candolle, son of Augustin de Candolle, who we met previously, publishes his Géographie botanique raisonnée. We'll circle back to him shortly. 1859. On the Origin of Species is published, taking Darwin's theory of natural selection public. The important contribution of Darwin should be evident from his place on the timeline, not evolution, but instead natural selection. 1865. Gregor Mendel presents his work, famous from school textbooks around the world, and published the following year, but not recognised until 1900. He experimented with crossbreeding different varieties of pea plants, and he found that certain characteristics would disappear or segregate instead of blending as was perceived wisdom. These factors, as he called them, could be masked by other factors, but reappear in future generations. Mendel was able to quantify ratios that would set the framework for early genetics. 1866. Ernst Haeckel, zoologist, naturalist, populariser of both scientific racism and eugenics, publishes General Morphology of Organisms, General Foundations of Form Science, and grounded by the descendants theory reformed by Charles Darwin, and in this work he coins the word ecology. 1882. Alphonse Pyramus de Candolle publishes Origin of Cultivated Plants, which tries to describe each domesticated plant species and place it in historical context. I love this book, and we'll study it in detail another time. De Candolle makes a clear effort to use linguistic and historical evidence from Asian cultures alongside the more familiar classical history and myths in placing the origin of various domesticated species. As the century draws to the close, we get the eclipse of Darwinism. Natural selection is sidelined by various other competing schools of evolutionary thought. 1895. Horses, asses, zebras, mules and mule breeding looks at species and hybrids for their practical uses, includes long sections of letters and older articles. In 1906, Bateson, who rejected natural selection, coins the term genetics to replace Mendelism as the name for the science of heredity. In 1922, J.B.S. Haldane formulates his rule. So let's explain Haldane's rule. Essentially, it describes what happens when two populations crossbreed. You're probably familiar with the idea that hybrids such as mules are sterile. Maybe you've heard that male lion-tiger hybrids are always sterile, but that female hybrids sometimes successfully breed back, either to tigers or to lions. In birds, however, this is reversed. Hybrids between different bird species often lead only to male hybrids, or are the only fertile hybrids being male. This is a puzzle Haldane was able to solve with reference to their chromosomes. Most mammals have a pair of sex chromosomes, either XX or XY, although obviously there are variations of karyotype, intersex individuals exist, and of course humans have a concept of gender, which is not the same as biological sex, and I'm fully supportive of trans identities. Hopefully you guys already watch ContraPoints. But birds have different chromosomes. A male pigeon has ZZ sex chromosomes, a hen has ZW. In mammals, males are heterogametic, containing two different sex chromosomes, X and Y, but in birds it's females that are heterogametic, Z and W. Haldane identified that the pattern in nature is that when, from a hybrid cross, one sex is absent, rare or sterile, it will be the heterogametic sex. In 1930, R.A. Fisher publishes The Genetical Theory of Natural Selection, which initiates the Fisherian synthesis, solving, according to Ernst Mayr, reflecting back on this from the 1990s, one of the two major problems of evolution, how species adapt, but it could not explain how new ones arise. We haven't met Mayer yet, but in a decade he will burst onto the scene in a debut book that will take him from obscurity to one of the most influential taxonomists in history. Prior to Fisher, many old models that had predated natural selection were still clinging on. Ideas that Lamarck held, such as orthogenesis, the idea that things change towards a directed goal, or his model of evolution developed prior to Darwin and Mendel's discoverers, were, I argue, much more reasonable positions when Lamarck held them. However, by this point, Lamarckism is now really neo-Lamarckism. To make the distinction between Lamarck's contemporaries and followers in the 1800s, who followed the best model based on the evidence they had, compared to the neo- or new Lamarckians, who by the 1920s and 1930s are predominantly reactionaries, opposing new models of evolution that applied Darwin and Mendel's mechanics to Lamarck's concept. 1935. During the Dust Bowl in the USA, Paul B. Sears publishes Deserts on the March, a popular science book that explained the human causes of desertification. In 1937, Theodosius Dobzhansky publishes Genetics and the Origin of Species, which initiated the second synthesis, focused on biodiversity. However, Dobzhansky recognises that taxonomy in North America is not very well developed and is largely based on typology, so he finds someone who can write a companion to his book. 1942. Ernst Mayer's Systematics and the Origin of Species from the Viewpoint of a Zoologist, systematics is synonymous with taxonomy, is published and revolutionises taxonomy in North America. This book also puts forward his biological species concept, which is often summarised as if two things interbreed then they are the same species, and is sometimes held up as the fundamental definition of species by lay people. In 1962, Rachel Carson's Silent Spring first raised public consciousness around a new environmental impact of human activity, the bioaccumulation of pesticides. In 1964, Paul B. Sears published The Biology of the Living Landscape, which illustrated various ecological situations and their relationships to humanity, and reflected upon the changes over his lifetime. In 1973, Lee Van Valen formulates Foster's Rule, based on J. Bristol Foster's work from 1964. You might not recognise the name Foster's Rule, but it's a very widely known phenomenon, that animals on islands are often larger or smaller than their counterparts from continents. I highlight this both because it's an important rule to bear in mind when we come to think about taxonomy and speciation, but also because it's another good example of something we see over and over again in literature. Mayer's Systematics from the Viewpoint of a Zoologist, 30 years earlier than Van Valen, notes there was a theory that insular populations generally became smaller in body size, but this idea has now been challenged because there are examples of the opposite happening. 30 years later, this would not be seen as a contradiction to a previously perceived rule, but reinterpreted as the other half of that rule. How can insular dwarfism be right, when we also have examples of insular gigantism? Well, to look at just one factor, lack of predators, that can allow medium-sized birds such as the pigeon to develop into much larger birds like a dodo. A lack of predation also allows large herbivores to shrink, as they no longer need mass to protect them from predators. Island populations generally can't migrate to find new food sources as easily, so smaller animals with less demand for resources often benefit. 1979, Ernest Small publishes The Species Problem in Cannabis, which I think is one of the best, most underrated, and sadly rarest books on taxonomy. Why problematic taxonomy? Well, first off, it's a play on the species problem, the debate in taxonomy around defining what a species is. Secondly, many texts and experts I want to present have elements that will be problematic to any modern audience. And lastly, because there is another area of taxonomic studies, a rather disreputable area in modern times, the study of hybrids, which I find particularly fascinating and illustrative of many common misconceptions around species concepts. If there's one point I'd like you to bear in mind from this episode, it's that ideas are often floating around long before they're able to be codified and quantified. We have seen firsthand that there was some awareness of domestication syndrome centuries before the phrase entered our lexicon, and there were echoes of Foster's Rule long before it was finally formulated. In the next episodes, we'll be diving deep into John Moore's Columbarium and the books that descended from it, with the help of experts from many of the UK's pigeon societies. We'll encounter religious bigotry, classism, bird fraud, and maybe even learn why the pigeon is still so beloved by many fanciers today. Sources for this episode include links to all the texts I could find available online, and can be found on the Problematic Taxonomy blog at education.uk, along with an audio episode teaser, some of the interviews that will be coming up in future episodes. Thank you for listening. Please subscribe for Taxonomy.